Hello and welcome to Intro to C. I'm Bill and today we're going to learn about arithmetic operators. Arithmetic operators allow us to do basic mathematics. So there's addition, subtraction, multiplication, division, and so on and so forth. So we're first going to talk about is the binary arithmetic operators. This means it takes two kind of like parameters. So first I've kind of declared some variables. I've declared x, y, and z. I've assigned x to be 10, y to be equal 4, and z nothing at the moment. And then whatever z is going to be when we declare it, we're going to print it out. So I'm going to declare z to be here, and I'm going to say z is now, I can either again do it in line or on another line after we declared it. It doesn't make a difference. And again, it's same here with x and y. So I could do x, and then I could do x equals 10 here. It doesn't make much of a difference. So int z equals, I'm going to say x plus y. And guess what? This is how we do our first binary operation. It's dead simple. So C says x plus y equals z. Very simple. And if we click F5 to build and run, we should be able to guess this produces 14 because 10 plus 4 is 14. So if we do subtraction, we do a dash there. So 10 minus 4 is 6. Let's see what happens. We get 6. It's brilliant. Now to do multiplication, we use the asterisk symbol. This is our for multiplication. We can't use anything else. And hey presto, we get 40 because 10 times by 4 is 40. Simple enough. Division, we use a forward slash. That's how we do division in C. And then 10 divided by 4 is 2.5. And what we get is, 2. So this is weird. This is because interdivision truncates any of the fractional part. So if you remember, integers only store again the integer part, the whole number part. If we wanted to do floating point division, we must use floating point numbers. I'll come on to this in a little minute. We'll only work with integers at the moment. So that's what happens. And then the last operator we're going to look about is the modulo operator, or the modulus operator, which is used by the percent sign. The modulus operator produces the remainder when x is divided by y. So the best way to think of this is 4 goes into x 4 goes into 10 2 times, remainder 2. So 4 times by 2 is 8, which is 2 off from 10. So the number we should get is 2 in this case. And hey presto, we do. So if I change y to be 3, so 3 goes into 10 3 times, remainder 1. So the value we get is 1. And yes, we do. It's simple enough as that. So if a number divides directly into the x exactly, then the value there'll be no remainder, it would be 0. So if we did 10 to the remainder of 5, we should get 0 because 10 is divisible by 5. There we go, perfect. It's exactly as we expect. This could be used to figure out leap years or something. Like a leap year happens every 4 years, but it doesn't happen not every 100, except it's every 400. Again, leap years are complicated. But again, it's very good to find if an integer is divisible by a number. And again, this operator cannot be applied to floating point or doubles, floats or doubles or long doubles. So don't use it. You'll have to use something else which will show on much later on in the series, and in fact we'll probably implement it ourselves as well. I'll show you how to do it. So they're the basic operations. So now we're going to talk about how you do this to floating point numbers. So if I'm going to write floating point for all of these, so change all the ints to floats, so we can do floating point operations, and then change that %d to be %f. So remember when we write percenting numbers from our previous episodes, we have to write our prefix on the end, so 0.0f. We can remove that 0 if we needed to, but I like putting it in anyway to explicitly say this is a floating point number, and it's got a fractional part to it. So if we do the same stuff again, so we say x plus y, we get 14.00 some numbers, yeah. X minus y, we get 6. If we do x times y, we get 40. You can see where this is going now, don't you? X divided by y, we get 2.5. Now we've got that fractional part, it works. And then we cannot do the modulus thing, and Visual Studio says, you can't do this. It must be an integer type, or an integral type as it's saying here. So there we go. Very simple. I won't be talking about anything, the stuff that complicated, like for instance, if a number is too big to be added, some stuff happens. They'll be talking about in the next series. So the next module in this chapter, thingamabob. So now we're going to talk about are the unary operators. Now the unary operators, again, only work on one variable at a time, or one number at a time. So these unary operators are plus and minus. So there is one that may seem a bit redundant, but you can do plus y. So this means times by 1 to y. So z should be equal to 4. Simple enough. And then the other unary operator is minus. So I could do minus y, which should be minus 4. Very simple. So there are all the basic operators, the basic unary and binary operators. But now we're going to talk about the precedence of them. So the order that they happen in. So if you remember from probably school, you may have learned about BOMDAS or BODMAS or whatever it's called, where there's an order of operations that goes on. So the order of operations are that brackets happen first, then it's the higher level operations like powers, then it's the multiplication, then division, then addition, then subtraction. So if I wrote the number, I'm just going to write numbers in here instead of variables. If I wrote 3 plus 5 times by 6 minus 1, what do you think is going to happen? So remembering from our orders of operations, multiplication happens first. So it's going to be 5 times 6 is going to happen first. So that's 30. Then addition is going to do add 3, so that's 33. Then subtraction, it's going to be minus 1. So if we run this, we get 32. That's exactly as what we expected. And I'm going to just change these back to ints because we're talking about just basic operations now at the moment. Just quickly go through this and change everything back to ints. If you wanted 3 plus 5 to happen first, you need to put these around with parentheses or round brackets or whatever you want to call them. So now 3 plus 5 is going to happen first before the multiplication. So 3 plus 5 is 8 times by 6, which is 48, and then minus 1, which is 47. Base math is not good for me. And then you get 47. That's exactly what we expect. Now, C kind of has these orders of precedence. So the ones that take the most order, again, are parentheses. They're the top dog, in a sense. The next one are the multiplication, division, and modulo. Then it's the addition and then the subtraction. There is some more. These unary ones actually take the highest, which is in turn highest operations, which are up here. So these are the unary ones. So I could say, instead of 3 plus 5, I could say minus 3 plus 5 times by 6 plus minus 1, which would be 49. Oops, if I get rid of them first. So comment these out. Oops, like so. And then it should still work. And here we get minus 49. So the unary has happened first. So order of precedence is unary operators first, then the braces, then those addition, division, multiplication, division, and modulo, and then additions and subtraction. So that is the basic arithmetic operators that you can do. So thank you for watching. Please experiment with this and have fun programming.